Today I will be talking about organic chemistry and we'll be talking about polymers. Now, I think my handwriting wasn't neat in the last couple I recorded, so I'm going to start making my handwriting a bit neater. That wasn't a good example, but anyway. Polymers, alright, so we all know a monomer. Well, I'm assuming if you're doing this course, Foundation Chem, you already know Foundation Chemistry. You have to know basically what an atom is. You also need to know what states of matter, chemical reactions, compounds, molecules, ions, electron configuration, acids, bases, and you also need to also like to know what a mole is. That's what I cover in the Foundation Chemistry. You all need to know that before even attempting organic chem. Organic chem is harder organic compounds and complex molecules. So let's start with a monomer. I'm going to start with methane, which is CH4. Basically, all monomer is this. So this is the drawing for methane. It's just one of these hydrocarbons, right? You should already know a hydrocarbon is essentially just hydrogen and carbon atoms. Just. If you've got an oxygen or another atom in there, it's no longer a hydrocarbon. Just hydrogen and carbon. No others. So methane, but you were to say, okay, Dylan, so what's a polymer? Well, a polymer is the monomer is just one, meaning mono, which means one. Then we've got a polymer. All a polymer is, right, is we just put a bunch of these together in a chain as long as we bloody like. That's all a polymer is. It's just a longer monomer, a chain of monomers. So we're going to have to say this. We're going to have a new hydrocarbon. And I believe this one is called ethane. Don't count me on that, I might be wrong. In fact, I've got my glossary chem. If I made a mistake, I'll put it on the website, Dylan Teacher Science. So this is a polymer, essentially. It's just two methanes connected together. That's all it is. That is literally all polymers and monomers are. But that's for fuels and hydrocarbons, you might ask. What about sugars and other cool shit? Well, I'm going to tell you this. So we have a monomer. What's a monomer for, say, a sugar? It'd be glucose, C6H12O6. But what if I were to combine multiple of those? Good news, you can. Using polymers, you can actually connect multiple sugar chains and make like more complex sugars. So essentially, I forgot how to draw glucose, so don't count me on this, but I might have drawn this wrong. So I think that's it. I might have drawn this wrong, so please don't count me on it. Alright, let's just say that's glucose. I think I've drawn it wrong. Maybe I'll put a proper drawing up on the website. How about that? So let's just pretend this is glucose, right? If I put two of these together, boom, we've got a new compound. I don't know what it's called. I think it's saccharose or something. But that's a new compound. It's a monomer we've essentially put to a polymer. Now, can we do it for anything else? I think you can, actually. So, I'm going to get into a new thing, but this is probably not really a... Well, next time we're going to go through hydrocarbons and carbohydrates in more detail. But for now, I'm just going to tell you the basics. I'm going to get into a bit more complicated stuff now. Functional groups can also be turned to polymers. If you ever see something like this, now this is more lesson 4, but I'll teach you guys now. What does the R mean? The R means random hydrocarbon chain. Essentially, you can put any hydrocarbon you want there. And this is an example, don't worry about this for now. This is an example of an aldehyde. Okay, this is an aldehyde. So for example, I could draw this long structure. So for example, I could just have, say, methane here, CH4, and I can do this. So that's a carbon. That's a hydrogen. Bloody hell. Boom, we've just connected two to make a functional group. But basically, don't worry about that too much. All you need to know about is that these chains can be infinitely long. There is no set number. They can be as long as you like. We could have something, for example, I don't know. So we've got C6H14, which is, I think, hexane, right? we could basically make that C1200 H, that'd be 2402. We could make a hydrocarbon that long. These chains can be infinitely long. Now, one more thing I do want to talk about is these. I'll talk about these more in the next lesson, but I'm going to briefly touch on them. Alkanes, alkenes, and alkynes. I'll touch more on these in the next lesson, basically. But that's what we're going to be covering next lesson, so next lesson will be these. I will also be talking about fuels such as hexane, methane, etc. And that'll basically be it. Stay tuned for next lesson.